The figure shows the graph of f of x. Use the graph to solve the inequalities and put them in interval notation. So in part A, we are asked to find all the x values such that g of x is between 1 and 2, including 1 and 2. Remember, g of x is just like your y value. So this is basically saying when are the y values of this graph between 1 and 2. So all I'm worried about is when are the y values trapped between 1 and 2. So if I go focus on the graph where that might happen, it looks like I'll be looking at 1 for the y value, which happens somewhere here, and then 2 for the y value, which happens somewhere there. So when are the y values trapped between 1 and 2 is basically here and here. That's where the y values are trapped between 1 and 2. Now what x values actually give me those y values? I can look down, in other words, look at the intersections. So the x values that give me y values between 1 and 2 are in here. And since there's equal signs, I have to keep them closed, filled in dots. And also the y values trapped between 1 and 2 occur at these other x values. So if I refer back to the x-axis, y values are between 1 and 2 if x values are between -3 and -2, or between 2 and 3. And it's said to give the answer in interval notation, so I'm going to walk left to right. The first number I hit is -3. I use brackets because it's a filled-in dot, comma. I stop at -2, close bracket again. Then I pick up again at 2, so union, bracket, pick up at 2, comma, stop at 3. So the x values that satisfy this statement for the y values are between -3 and -2, including the endpoints, and between 2 and 3, including the endpoints also. For part B, I'm interested in g of x less than or equal to 6. So I don't need to look at what two y values it's trapped in between. I just need to find out when the y's are less than or equal to 6. So let's get rid of this business. So this statement is basically saying g of x, which is y is less than or equal to 6. So I'm supposed to find out for which x values the y values remain less than or equal to 6. So let's go find the y value of 6 and draw a line through it, horizontal line through the y value of 6, and I have to find the x values that are corresponding to all the y values being less than 6. Well, if you pay close attention, every single y value on this curve is definitely less than 6 or equal to 6. So if I were to figure out or keep my eye on when the y values are less than 6, it definitely happens all the way through the whole curve. Through the entire curve, we have y values that are less than 6, or at the very top, exactly equal to 6 also. So what x values actually give me y values less than 6, you can visually see pretty much all the x values possible give me y values less than or equal to 6. So if all x values for this graph satisfy that y is less than or equal to 6, then what do I shade on my x-axis? I shade everything, because every single x outputs a y value less than or equal to 6. How do I give that an interval notation? Well, if I'm walking left to right, I'm coming all the way from -infinity, and I keep walking forever to positive infinity. So in interval notation, it's -infinity, comma, to positive infinity. That means it covers the entire real line. Every single x value possible that you input into this function will give you an output that is either 6 or less than 6. Now when you use x, y, z, if you look at that little orange box that tells you how to input your answer, make sure you use O's, the letter O on your keyboard for infinity. So two O's, they say, will denote infinity. So you'll have two O's, or you'll have a negative sign with two O's to denote negative infinity. Let's look at one more. It says that again the graph of g of x is given. Solve the graph, or look at the graph to solve the inequality visually. So here we have g of x, which is really the y values. When are the y values greater than 14 is basically what it's asking me to find. So I'm going to go to the y value of 14. So it looks like it's going up by ones, 1, 2, 3, 4, and so forth. So 12, 13, 14. I'm interested in what happens at the y value of 14. And I have to keep all the stuff that are bigger than 14. So all the y values bigger than 14 are these guys. Those are all the y values that remain bigger than the y value of 14. In other words, above the y value of 14. Now I have to figure out what x values correspond to that, so I just have to look down at my graph and see what x values give me that. And it looks like from 12 on, all those x values will keep the y values bigger than 14. And since there's no equal sign, it looks like I will have an open dot shaded to the right. So all the x values greater than 12 will keep the y values above 14. So my answer in interval notation, as I'm walking left to right, the first number I hit is 12, parentheses, comma, and then I keep going forever and ever, 12 to infinity. Part B says, when is g of x less than or equal to 11? So let's get rid of this stuff. When is g of x less than or equal to 11? In other words, when are the y values? Actually, there is no equal sign. It's just g of x less than 11. So when are the y values less than 11 is basically what that's saying. So I'm going to go to the y value of 11. So I'm at 8, 9, 10, 11. I'm going to draw my horizontal line through 11. And now, since this is saying when are the y values less than 11, I have to keep everything that is below 11. So all the y values have to be less than 11. Which means I have my eye on this portion of the graph. These are all the y values that are less than 11. All these y values are above 11. All these y values are less than 11. Now what x values actually give me those? So let's go figure out where the intersection was. It looks like it happens at 4, 5, 6, and to the left. So all the x values from 6 and to the left of it looks like gives me the y values that are less than 11. And again, since there's no equal sign, I'm going to have an open circle and shade everything to the left on the x-axis to get my solution. So in interval notation, I'm walking left to right, so I come all the way from left, which is negative infinity, comma, I keep going and I stop at 6. Parentheses at the end, again, because there was no equal sign involved.